Hello, my friends. In this video, we will be taking a look at the autosomal DNA results, predicted phenotype traits, and GED match results of an Ashkenazi sample from Germany, from Erfurt, Germany in the 12th century. So this Ashkenazi Jewish sample is a part of a very large cluster of samples from Germany. Now, there's actually two clusters that these Ashkenazi samples fall into. One cluster is the samples cluster that is typically Jewish, which clusters with Sephardic and modern Ashkenazim Jews, and the other cluster is the cluster that has European admixture. So this sample actually falls within a cluster that has a slight amount of European admixture, which we will see with the GED match oracle right now. Euroginske 13 shows that this sample is closest to the Greeks from Thessaly, followed by Bulgarians, followed by Romanians. So these are European populations that this sample is closest to. And in fact, it is getting modeled as a mixture of 74% Ashkenazi plus 25% Southwest Russian, or 74% Ashkenazi plus 25% Ukrainian Belgorod, or 76% Ashkenazi plus 23% Belarusian. So it is getting modeled as a mixture of roughly three quarters Ashkenazi plus one quarter Slavic. So this sample has a very significant amount of Slavic or Eastern European admixture. So this is one of the samples that is probably the highest in terms of the non-Ashkenazi admixture in these Erfurt Jewish samples from Germany. This is probably why my viewers suggested this sample to me, because this sample is so high in the non-Jewish admixture. We can try to run this through another calculator. Let's try to run this through the calculator that's very good at telling ancient components, which is MZLP World K11E. This does not have an oracle, but it is very good at ancient components. Meanwhile, let's look at the map of where Erfurt is located. So it's located in central Germany right here, around the same latitude as Belgium, around the same latitude as Kiev, around the same latitude as Voronezh and Belgorod in Russia, and the very northern border of Kazakhstan. So this is quite a Central European city in terms of its location. And Jews from Erfurt, after they were expulsed from Erfurt in the 13th century due to pogroms, actually ended up going east into into Eastern Europe, where they ended up settling in Poland, Belarus, Lithuania, and Ukraine. So these Jews from Erfurt in Germany, Jews made a very large traveling route from Italy, from Southern Europe, where they first settled in Europe, then into Germany, and from there they made a route into Eastern Europe. So they traveled quite a lot for Europe, and even then in Eastern Europe they had pogroms there, from where they had to travel into the United States, and so Jews have been traveling quite a lot through history. This sample is done with MTLP World K11E. This is what it scores. So it's mostly scoring Neolithic Anatolian farmer component. Then it is scoring 25.5% EHG, which is really not EHG. It is really Caucasian hunter gatherer slash Iranian Neolithic farmer. So it's scoring a lot of Caucasus slash Iranian Neolithic admixture, which is typical for Ashkenazi Jews and populations of West Asia in general. But what is really interesting about this sample is that it's scoring 18.27% European hunter-gatherer component. By the way, WHG on this calculator does not refer to just WHG, it refers to all European hunter-gatherers. So this is WHG plus Eastern hunter-gatherer. But this is very high for an Ashkenazi Jew to score 18.27% WHG on this calculator. This is very, very high. And if you look at the oracle for this calculator, which there isn't an oracle on Admixture Studio, but there is an oracle on GED Match, which I'm banned from. But if you looked at the oracle on GED Match, this sample would score probably a mixture of something from Eastern Mediterranean, like Greek Bronze Age or Greek Iron Age, plus something from Northern Europe. This is what you would probably see with the oracle based on the results here. He's scoring. Actually, I think it's a she. It's a she, isn't it a she? But we'll find out. Okay, she's scoring 15% basal, which is basal Eurasian, which is also a very Ashkenazi thing to score. Actually, because of the basal, I think the result might not be Greek. It might be different. It might be instead showing a result like some kind of Levant Bronze Age plus maybe Central Europe or something. So because of the basil, it might not be Greek. Then 4.5% Iran Mesolithic, which is also this very exotic, very southern component that's ancestral to Iran Neolithic, but it's much more southern than Iran Neolithic. From my understanding, this is a simulated component. This is not a real component. Then 1.7% C, which is very interesting. 1.17% Siberian, 0.6% African, and 0.32% Oceanic. So these are all kind of like noise level components. But the C and Siberian is interesting because there are theories out there on the internet that Jews are part Khazar, that Jews have some Turkic or East Asian admixture for the Turks. So the Siberian and Sea admixture with MDLP World K11E would be quite interesting to explore. So let's go ahead and move on to the gender of the sample. The sample is indeed a female, as I said previously. So yes, this is a female. It's a girl, and her mitochondrial lineage is U1B1. So she carries the U1B1 mitochondrial lineage. In terms of the Nashakot calculator results, what she looks like, it looks like she's got brown or hazel eye color, brown, hazel, blue eyes with an amber center, or green. So some kind of an intermediate eye color. It's not a very precise prediction here, but she does not have dark brown eyes most likely, and she most likely does not have blue eyes. So she most likely has some kind of intermediate eye color. It's just brown, hazel, most likely brown or hazel actually. For hair color, it's a little bit more definite. So she most likely has dark brown hair. Light brown hair is also quite possible. Black hair is also quite possible. Dark blonde and light blonde hair is less possible here. So she most likely has dark brown hair. For skin color, she most likely has olive or Mediterranean skin tone. And for hair texture, she most likely has straight or wavy hair texture. Now for nose shape, she's actually scoring mostly snub shaped nose, which is very interesting. So for nose shape, she's scoring mostly the nose shape that's on the right, which is very unusual for Ashkenazi Jews. The stereotype is that Ashkenazi Jewish noses are like the nose shape that's on the left. So it's quite surprising that she's scoring the nose shape that's on the right as the largest percentage for 78%. So that's very interesting. For coloring related variants found in the file, she's got two light color variants here, so that's predisposing her to lighter pigmentation of eyes. But she does not have blue avotype 3, and she's got one light color variant in BH1. So that is probably why it's so difficult to classify her eye color, because of the two light color variants and all these variations of HERC2, but because not having BH3 and having only one heterozygous genotype in BH1, and also not having any genotypes in BH2 region, that makes classifying eye color really difficult. But I feel like with Snipper 3, she would probably score green or hazel for eye color. And of course, she also doesn't have this genotype here, which is another very important genotype for eye color classification. Um, okay, she does not have this genotype in SLC2485 either, but if she did, it would probably lead to a lighter eye color classification, but because most likely she has two light color variants here, as it is typical for Ashkenazi Jews to have. She does have two light color variants in these variations of SLC45A2, which is typical for Ashkenazi Jews as well. And she does not have any ginger variants in MC1R. Let's check what she scores for eye color with Snipper 3. I'm quite curious what she scores for that. I'm expecting green or hazel, but we will find out. And instead she scores brown, actually. That's very interesting. But green and hazel scores very close to brown. There is 1.8 times more likely brown than green or hazel. So green or hazel scores pretty much the same as brown with Snipper 3. So brown and green or hazel are quite close here with Snipper 3. Alright, let's look at the phenotype oracle for what she scores here. And the closest phenotypes to her are, it looks like, the Alpinate phenotype, followed by the Volgid phenotype. So these are both like kind of phenotypes that are slightly potato phenotypes, followed by this phenotype, which is a wow. What do we see for the two-way admixture? Oh, that's crazy. All right, we're gonna get to that in a couple seconds. So the third phenotype is a Mediterranean phenotype with darker features. But now that we get to the two-way admixture, let's look at that. Wow. So for the two-way admixture, she's getting modeled as a mixture of looks like a mixture of Amerindian plus Balted, or Amerindian plus Norded, or Amerindian plus Balted here, or Amerindian plus Balted with curly hair here. Did she score curly hair with Nashakot? Hold on, let's look at that again. I don't remember. Did she score curly hair with Nashakot? She scored wavy or straight or curly hair. Okay, all right. So, all right. This is quite interesting that she scores like that for the two-way admixture. This is quite interesting. Let's look at the facial morphology oracle. All right, so she's got 82%, 82.6% for Amerindian, then 0.65 for East Asian, 6.9 for Northeast European. This is, I think, for Middle Eastern. This is no. This is, I think, for Northwest European. This is, I think, for South Asian. All right, so she's mostly scoring Amerindian for the facial morphology oracle, and that can only be explained by one thing: scoring Amerindian for the facial morphology oracle, which would explain this result for the two-way admixture oracle. By the way, people have been telling me you should make coloring less relevant in the facial morphology. If I made coloring less relevant in the facial morphology, what you don't seem to understand, if I made coloring less relevant in the facial morphology oracle, she would not even be scoring Balted here. If I made coloring less relevant in the facial morphology oracle, she would not even be scoring the Balted. The bottom phenotypes would be gone here. It would just be the Amerindian. That's what's so crazy. So no, I don't think I will be making the coloring less relevant. I think the coloring will stay there as it is. But the only explanation I can come up with for why she's scoring so high for a Merindian is that she has East Asian ETAR variants. So let's look that up. And indeed she does. She's got heterozygous genotype in this variation of ETAR. One European ETAR allele, likely partially European. So it is common for Amerindians to have heterozygous genotype in ETAR. For East Asians typically have homozygous variants in ETAR. Europeans typically have no East Asian ETAR alleles. So it makes sense. Yeah, she's got one East Asian variant in ETAR. So that explains why she scores the way she does for the oracle, for the facial morphology oracle. Totally. She's also got a genotype for slightly thinner eyebrows and a genotype for lower odds of missing teeth. All right. Let's look at the biomarkers panel. For the biomarkers panel, she's got a higher level of vitamin D, a higher level of LDL cholesterol, a lower level of HDL cholesterol, which is kind of bad. All of that is kind of bad, except for the higher level of vitamin D. That's good. A higher level of glucose, a lower level of hemoglobin. Wow, that's good. A lower level of blood pressure. That's good. A lower level of iron in the blood. That's also good. That's good because it does means she does not have hemochromatosis. Um, but there is like different dangers that come together. I say in my reviews, I always say that's good that she doesn't have higher level of iron in the blood, but it might be bad as well because like lower levels of iron in the blood, there's different there's different issues that come together with that as well. So it might be bad as well to have lower levels. She's got lower levels, higher levels of sex hormone binding globulin, higher levels of red blood cell count in blood, lower number of base pairs for telomere length, and lower height, lower expected height. That's very interesting. Jews are stereotyped being quite short in Europe. Europeans always stereotype Jews as being a little bit shorter than them. So, but of course, it does not mean that she's really shorter than average. And like for example, I score a little bit shorter than average with this tool as well, but I'm quite decently taller than average. I'm like 6 foot, but I score 0.2 centimeters shorter than average height as well. So it doesn't mean anything. So okay. Uh, I think. Oh, did I look at the ethnic calculator? Let's look at the ethnic calculator results as well. Let's look at that. So I am not going to dwell on that, but let's zoom in and let's look at that. for a couple seconds. So this is 309 SNPs, and this is actually a pretty good result. Wow, this is actually one of those results where, based on 309 SNPs, it pretty much accurately, spot on, captured the ancestry of the sample. I am very much impressed with the result for ethnicity in this case, and this really goes to show you that my ethnic calculator that I made, in some cases, it by accident gets the ethnicity completely correct. But I'm not gonna dwell on this result for too long. Just take a screenshot or maybe pause the video and move along. Okay, now let's go ahead and look at the polygenic risk scores. Okay. We are going to ignore. Oh, come on. I'm so tired of these ads. Okay, so we're going to ignore everything that is close to 1 and only going to look at the scores that are very distant from 1. So she's got a very low score for hemoglobin E disease. She's got a very low score for arrhythmia nodosum. She's got a high score for migraine. Wow. Very high predisposition to migraine. She's got low predisposition to gout. She's got slightly below average predisposition to polycystic ovary syndrome, which is good. She's got slightly above average predisposition to age-related macular degeneration. She's got slightly below average predisposition to rheumatoid arthritis. She's got slightly above, actually very high predisposition to leukemia. Wow, very high predisposition to leukemia. That's very crazy. Very low predisposition to vitiligo, low predisposition to myopia, slightly above average predisposition to corneal astigmatism, slightly above average predisposition to primary biliary cirrhosis, higher than average predisposition to stroke. She's got below average predisposition to deep vein thrombosis. She's got average predisposition to cardiovascular issues for the cardiovascular issues panel. Very typical, nothing too surprising. She's got average predisposition to unipolar depression. She's got low predisposition to bipolar type 1. And she's got low predisposition to schizophrenia. She's got high predisposition to type 2 diabetes. And she's got average predisposition to type 1 diabetes. She's got average predisposition to Alzheimer's. And she's got average predisposition to multiple sclerosis. She's got no risk variance for breast cancer out of 6. Wow, that's really good. She's got low predisposition to prostate cancer. She's got low predisposition to brain cancer. She's got low predisposition to thyroid cancer. She's got 2 JAK2 risk variants for blood cancers panel. So remember the Boogie 2988 controversy on the internet? It was a controversy where he faked having polycythemia vera, and he larped about having the blood cancer called polycythemia vera, and Destiny confronted him on stream, and he said, "Well, you never tested for the JAK2 genetic risk variants for polycythemia vera. If you had the blood cancer, you would have tested for the genetic risk variants." And Boogie just collapsed after that question. So I actually what I did when I looked at the what I did when I looked at the stream is I looked it up and I added that to my trait predictor. So JAK2 is now a part of my. This is so annoying, but JAK2 is now a part of my trait predictor panel. There's a blood cancers panel and it includes JAK2 gene. It looks for all the variants for JAK2. So she does have 2 risk variants for JAK2 for polycythemia vera. So Boogie doesn't have these risk variants, but she does. This Jewish individual from Erfurt does have these risk variants for polycythemia vera. 11 risk variants for testicular cancer out of 16. Very typical for Europeans to have these, especially in the variants in the KTLG gene. No risk variants for celiac disease out of 4, really typical. And we don't see anything else that's uncommon. Do we? No, we don't. For Gilbert syndrome, we see 2 risk variants here, but that's common. For Crohn's disease, we see 7 out of 14, which is actually really high, but none of them are marked as important, so we can ignore that. Alright, so that's nothing is too surprising. I did find the score for leukemia to be very, very concerning. Leukemia, typically, you're not supposed to score very high, so leukemia score is very concerning. We're going to look at that in a couple seconds. Let's look at the monogenic traits. So she's got the warrior phenotype for warrior versus warrior, which there's GG in Combs Valmet, GG in MAOA RS6323. So all these genotypes in Combs, MAOA, and MAOB lead to warrior traits, warrior phenotype, which leads to quicker dopamine reuptake, lower dopamine levels, and high stress resiliency. Very good stuff. For dopamine D2, she's scoring less dopamine D2 receptors. So in DRD2, she's predisposed to less D2 receptor sites, which leads to lower odds of bipolar and schizophrenia, which is really cool. So we saw that in the polygenic traits as well. She's scoring very low for bipolar and schizophrenia, 0.4 times the average odds. For 5-HT and serotonin, she's scoring lower levels for 5-HT and serotonin, so slightly higher predisposition to such conditions as anxiety and depression. For autism, she's scoring higher odds for autism, higher or intermediate odds for autism, so slightly higher predisposition to autism. And she is scoring intermediate odds for lactose persistence. That is because nothing was found for lactose persistence whatsoever in the file. There is no variants for lactose persistence that were found on the file, and that's what she's scoring. That's what you score when you have no variants in your file for lactose persistence at all. So that's like the basic score. That's the basal score for when you have no variants for lactose persistence in the file whatsoever. For empathy, she's scoring average level of empathy based on these 3 SNPs. She's not a carrier for the C282Y hemochromatosis mutation. Pretty cool. For Alzheimer's, she does not carry risk variants for Alzheimer's in the APOE gene, and she does not have any risk variants for multiple sclerosis in the MS gene, for multiple sclerosis in the HLA gene, excuse me. I rushed ahead of myself. For cardiovascular issues, she's scoring higher odds of cardiovascular issues. So from this, we already know that for the homocysteine panel, she must score very much below average risk odds, because she's scoring average odds for the cardiovascular issues panel on the polygenic risk score page, which means that her homocysteine panel must be good to offset the score that she's got for the cardiovascular issues page that you see here on the screen right now. Which means from that we can also draw the conclusion that her MTHFR genotype must also be good as well. So from this we can already draw 2 conclusions together just from looking at these 2 panels already. It's pretty cool how you can make these conclusions by looking at the results retrospectively, not retrospectively, I'm sorry, but by looking at these results even before you see them, you can already assume what they will look like, because so much of it is connected together. So this we already saw for facial morphology panel. Myopia, she's got 2 alleles that protect from myopia here. Wow, let's look at the myopia score, by the way. I'm curious to see what myopia score looks like. So she's got below averages for myopia. Alright, pretty cool. Okay. No risk variance for vitiligo and HLA gene. Pretty cool. No micropenis. Pretty cool. Typical increased impaired muscle performance, likely endurance athlete. Alright. 2 variants for increased sensitivity in SCN9A. That's pretty uncommon. That's kind of typical. Atypical. Alright. Okay. She's not a carrier for cutaneous albinism type 2 or type 1B, so she's not albino. And for the MTHFR, she's got, as I was predicting, she's got most common genotype, lower odds of various health issues. As I was predicting, her genotype in MTHFR is perfectly healthy, perfectly good. You could predict this type of stuff by looking at the panels in order as they are posted, because it's all interconnected together. It is all interconnected together. For cancers panel, she's scoring lower odds of epithelial cancers, alright, but I do want to see the leukemia panel. So for leukemia, there is no genotype in NQ01, but there are genotypes that predispose to higher odds of leukemia. It would be very interesting to see what her score for NQ01 are, but unfortunately that looks like that's not in the file. The file isn't very high quality in this case. Okay, what about the cancers panel, the 8Q24 region? So for 8Q24 region, it looks like overall her genotypes are really good, except for this genotype, but this is kind of typical. This is the most typical genotype, so it's not that big of a concern. For rare diseases and traits panel, it looks like she's got 20 times risk of ankylosing spondylitis. That's kind of uncommon, but it's like 4% genotype. Like 44% of people have this type of genotype. 4%, not 44, but it's pretty common. It's kind of rare, but it's still pretty common. And that's the only rare illness she is predisposed to. There is no risk variance for celiac disease in HLA gene. And she's got 2 protective variants in HLA for HIV, which is really, really good to see. No risk variants for Canavan syndrome. And typical higher odds for boldness in the androgen receptor gene panel. Now for the HLA gene panel, she's scoring lower odds of autoimmune disease. I don't think I will go for the HLA gene result because I don't think it's very important. We see that she's scoring lower odds for autoimmune disease. That already tells you pretty much everything we need to know about the HLA gene result. And for the homocysteine panel, she's scoring lower odds of homocysteine lower homocysteine levels, which is really good to see. So that's kind of what I was expecting from the get go. I was expecting she would score lower homocysteine levels because that's what you saw with the because that's what you had to assume because she scored very high for the um she scored very high for the cardiovascular issues result page on the result page panel on the main page, and she scored average for the risk of cardiovascular issues. She scored 1 for the risk of cardiovascular issues on the polygenic risk score page. So what conclusion can you draw from this? You have to draw the conclusion that the homocysteine level panel has to be good based on that because it has to offset, it has to um, mitigate, or it has to, what's the word for that? It has to mitigate, I think. Yeah, it has to. I have to look for the word. I have to look for the right word. Yeah. Anyway, I actually googled. I couldn't find the right word, but I think it's mitigate. So anyway, this result you can actually kind of assume what it's going to score because these panels are interconnected together. Uh, so she does score lower levels of homocysteine based on the homocysteine panel, and she does not have any risk variance for homocystinuria in the CBS gene, which is pretty good. For muscular dystrophy myopathy, she's scoring no risk variance for that, no risk variance for ADL either. For colorblindness panel, she's got no risk variance. Actually, nothing was found for colorblindness for any of the relevant genes at all in her data file. So the data file itself is not very high quality, as you can see. A lot of the stuff is missing, and it's not a very high quality data file. But people have been requesting that I make this video, so that's why I'm making this video. She's got intermediate or lower odds of obesity based on 1, 2, 3 S&Ps. So once again, not very high coverage for obesity, but there you go. And based on 2 S&Ps, she's got slightly higher than average odds for syncope. Um, she's got 2 copies of the farmer CLTCL1 gene variant, which leads to selective advantage in processing carbohydrate-rich diets, presumably including those with lots of sugar, which is really interesting. So she's got some advantage in processing carbohydrate-rich diets. And for blood group panel, her blood type is type A. Her blood type is most likely type A blood type. So thanks for watching my video until the very end. Make sure you check out the description of the video. It has a lot of really cool stuff, such as the links to buy my trade predictor software, which I use to generate these trade reports. There's also the link to buy a trade report with my trade predictor, which costs only $4 currently. And also make sure you check out the like button and the subscribe button for my channel. And thanks for watching. Goodbye.